Good morning students. What are seen in the previous class now? That is construction and working of tangent galvanometer. What is tangent law and how to construct the tangent galvanometer? What are the parts that will be in the tangent galvanometer and what is the theory it will be used to work a tangent galvanometer? That all are discussed in the previous session. Okay. In the today's session I explained that types of magnetic materials. What is the meaning that magnetic materials? One material is having magnetic property, it will be called as magnetic materials. So what are the types of magnetic materials? Due to the property, the material will be classified into three, that is dia, para and ferro. Okay. Dia having magnetic property, magnetic power it will be less, and ferro it will be having the strong magnetic power. Okay. So dia, para, ferro, the three type of magnetic material it will be classified on the basis of some properties. Okay. So I explained in this session what are the types of magnetic material and Meissner effect, Curie's law and Curie's Weiss law and spin, that all are discussed in the today's session. Okay. So first on the basis of some property the magnetic material it will be classified in three. So first I explain what is the properties. Okay. Magnetizing field, magnetic dipole moment, susceptibility, permeability, that all are you have to learn before enter this topic. Okay. So first magnetizing field. What is the meaning that magnetizing field? Which magnetic field it will be used to magnetize a material, that will be called as magnetizing field. எந்த ஃபீல்டை யூஸ் பண்ணி ஒரு மெட்டீரியலை நீங்கள் மேக்னட்டாக மாற்றுறீங்களோ அந்த ஃபீல்டுக்கு பேர் மேக்னடைசிங் ஃபீல்ட். ஓகே. ஸோ the magnetic field it will be used to magnetize the material, it will be called as magnetizing field. Okay, clear that? So first magnetic dipole moment. So magnetic dipole moment, what is the meaning that magnetic dipole moment ma? Magnetic dipole moment is nothing but P vector is equal to product of pole strength into the distance between the 2 points, distance between the 2 poles. Okay. So magnetic dipole moment P is equal to Q into 2D, Q into 2D, that is the magnet. 2D means 2L. Okay. So this is the distance between the 2 poles. Okay. Magnetic dipole moment is nothing but magnetic dipoles it will be move. Okay. It will be equal to the product of pole strength and the distance between the 2 poles. Then force already you have to know, magnetic force. Then magnetization. Magnetization means you have to apply the field. Okay, that the material will be magnetized, that the property it will be called as magnetization. So first I explain the first property, that is magnetic dipole moment. Magnetic dipole moment is nothing but B vector is equal to product of pole strength and the distance between the 2 poles. Okay, Q into 2L. So magnetic dipole moment for diamagnetism, for diamagnetic material, no resultant magnetic moment. What is the meaning that no resultant magnetic moment? It will be moving in a forward, no net magnetic moment. For example, எல்லா particles of material எல்லா மூமெண்ட்டும் it will be moving in a forward direction, no net dipole moment. Net dipole moment அதுக்கு கிடையாது. Okay. So no resultant magnetic moment is not there. Is there in magnetizing field is absent. So without the magnetizing field no resultant moment is there. Okay. So with applying the magnetizing field, magnetic moment is there, it will be arranged opposite to the field. For example, if the magnetic material diamagnetic material is there, you have to apply the magnetizing field to the material, the magnetic moments it will be arranged opposite to the magnetizing field. Okay. So the magnetic moments in the diamagnetic material it will be arranged opposite to the magnetizing field. Without the magnetizing field no net dipole moment is there. Okay. And for diamagnetism, in the absence of magnetizing field, net magnetic dipole moment is zero. Is there, net dipole magnetic moment is there, but it will be zero. What is the meaning that some magnetic moments it will be in a forward direction, another one it will be moving in the opposite direction. It will be add to calculate the net magnetic dipole moment, it will be zero. Magnetic dipole moment na ஒண்ணும் இல்ல, magnetic material இருக்கக்கூடிய அந்த material particles move ஆகும், அதான் magnetic dipole moment. நீங்க டயா எடுத்துக்கிட்டீங்கன்னா டயால in the absence of magnetizing field no net dipole moment. Net dipole moment is not there. Net dipole moment means நீங்கள் ஆட் பண்ணும்போது அதோடைய வேல்யூ வந்து இருக்காது. But in the presence of magnetizing field, the magnetic moments it will be arranged opposite of the magnetizing field. You have to apply the magnetic field in the forward direction, but the magnetic moments is there in the opposite of the magnetizing field. Okay, and then in paramagnetic field, the magnetic moment it will be aligned parallel to the magnetizing field. This opposite, this is parallel to the magnetizing field. Okay, but net the magnetic dipole moment is there. Okay, ferromagnetic material also net magnetic dipole moment is there. Net magnetic dipole moment na enna onnu illa, some magnetic particles will be arranged in a forward direction, another magnetic particles will be arranged in the opposite direction. That it will be at the net magnetic dipole moment will be 0. Is there in the para and ferro, but in contained we consider the ferromagnetic material, the magnetic moment will be considered as the domains. Okay, so the magnetic materials will be arranged. For example, this is a ferromagnetic material. Okay, magnetic moment is there, but the forward direction will be considered as one domain. The opposite direction will be considered as one domain. This is also 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 one domain. Domain is nothing but magnetic moments is considered as one packet. Or a bunch of magnetic moment at that domain we consider. Okay, so domains in the ferromagnetic materials it will be parallel to the field. Sometimes some domains it will be arranged aligned to the field. Okay, some domains in the ferromagnetic materials it will be arranged parallel to the field, and some domains it will be arranged align the magnetizing field. Okay, so first point is magnetic dipole moment. Magnetic dipole moment means a magnetic material it will be moved in the magnetic material part. So magnetic movement in the absence of magnetizing field, no resultant magnetic moment is there. Net magnetic moment dipole moment is there. Net magnetic dipole moment is there. Then magnetic moment it will be arranged opposite of the magnetizing field. Magnetic moment it will be arranged along the direction of magnetizing field. The domains in the ferromagnetic materials it will be parallel. Some domains it will be arranged parallel to the field. Some domains it will be arranged aligned to the magnetizing field. So okay, so this is the end, and second point is force. So what is the magnetic force that will be arise? The magnetic force due to the non-magnetic dipole moment, the material it will be moving stronger part to weaker part. Okay, so we applying the force in the non-magnetic field, non-uniform magnetizing field. யூனிஃபார்மாக இல்லாத ஒரு மேக்னடைசிங் ஃபீல்ட் நீங்கள் அப்ளை பண்ணுறீங்க அப்படின்னா, the materials it will be moved from the movements it will be present from stronger part to weaker part. ஸ்ட்ராங்காக டென்சிட்டி வந்து எந்த இடத்துல ஸ்ட்ராங்காக இருக்கோ அந்த இடத்துல வந்து வீக்கர் பார்ட்டை நோக்கி மூவ் ஆகும் இந்த மெட்டீரியலுடைய மூமெண்ட். பட் in the paramagnetism the material movement is there from weaker part to stronger part. By in the ferromagnetism weaker part to stronger part. Clear that ma? So force it will be applied to the magnetic materials in the magnetizing field, in the non-uniform magnetizing field. The material movements is there from stronger part to weaker part. This weaker part to stronger part, weaker part to stronger part, weaker part to stronger part, easily that the material will be magnetized. So magnetization power it will be high for para and ferro comparable to the dia. Okay, and what is the third point ma? That is magnetization. We apply the magnetic field that the material it will be magnetized, that the property it will be called as magnetization. Okay, so we draw one graph as on the end we taking the x-axis in the magnetizing field and y-axis of magnetization. Magnetization is the process to magnetize a material by applying magnetizing field. Okay, clear that? So we taking the magnetizing field it will be in x-axis, and we taking the magnetization in y-axis. We get a graph, it will be straight line, but it will be in the opposite straight line because the value it will be first attain a maximum level and it will be decreases in the x-axis or y-axis. Okay, high point and low point and that is diamagnetic material. And paramagnetic material, the magnetization it will be increased with the increasing magnetizing field. So we have to increase the magnetizing field, the magnetization it will be gradually increases. But the diamagnetic material, the magnetizing field it will be increases, the magnetization it will be in a decreases. So instantly the magnetizing field it will be applied to the particle, the magnetization it will be higher. So we increase the magnetizing field, easily the magnetization it will be reduced in diamagnetic material. But para magnetizing field you have to increase, after the magnetization property it will be also increases. And ferro, the magnetizing field it will be increases, first increases, and magnetization it will be going in a constant due to the magnetizing field. That is the three graphs it will be straighter. First graph it will be getting the opposite straight line, or opposite straight line means it will be reach the increasing high level and it will be decreases with the magnetizing field. Second one, it will be gradually increases with the increasing magnetizing field. Third one, first increases and attain a high level, it will be goes on to the constant value. Okay, that is the magnetizing field and magnetization. And what is the symbol ma? That is susceptibility. What is the meaning that susceptibility? What is the meaning that susceptibility? Susceptibility means magnetization by magnetic field, ratio of magnetization by magnetizing field. What is the meaning that magnetization by magnetizing field? Susceptibility it will be decide how the material it will be magnetized to be strong or weak. ஒரு மேக்னெட்டிக் மெட்டீரியல் ஸ்ட்ராங்காக வந்து மேக்னடைஸ் ஆகுதா லைட்டாக மேக்னடைஸ் ஆகுதா அப்படின்னு டிசைட் பண்ணக்கூடிய ப்ராப்பர்ட்டி தான் சசப்டபிலிட்டி. சசப்டபிலிட்டி இட் இஸ் த ரேஷியோ ஆஃப் மேக்னடைசேஷன் பை மேக்னடைசிங் ஃபீல்ட். Magnitude of magnetization to magnetizing field, okay, m by h. So susceptibility it will be positive for diamagnetic material. For positive, negative. What's the meaning that negative ma? We improve the magnetizing field, but magnetization will be decreases. So the susceptibility value will be negative. Susceptibility value for positive and very small in the paramagnetic material. Susceptibility value will be positive and large in the ferromagnetic material. So susceptibility is nothing but is the predominant factor to decide how the material to be magnetized, strong or weak. Okay, so susceptibility it will be the ratio of magnitude of magnetization to magnitude of magnetizing field. Okay, susceptibility will be negative for dia, positive and small for para, positive and large for ferro. Okay, and that is mu r. What is statement? Mu r means relative permeability. What is the meaning that relative permeability? What is the meaning that permeability? Ability to permit magnetic field through their own way. That is which material will be allow the magnetic field to pass through them. That the material will be having permeability. Okay, permeability na enna ஒரு மெட்டீரியல் மேக்னெட்டிக் ஃபீல்டை தவளையாக கெட் பண்ணி வாங்க முடியுது அப்படின்னா that is called permeability. Okay, permeability in medium, permeability in air. Permeability in air it will be stated as mu naught. Okay, permeability in medium it will be stated mu m. But mu r is relative permeability. What's the meaning that relative permeability? Relative permeability means relative permeability will be give the ratio of permeability in medium and permeability in air. Okay, so relative permeability will be straight the ratio of permeability in medium to permeability in air. Okay, mu by mu naught, that will be called as mu r. So relative permeability is less than 1 in diamagnetic material, less than 1. It will be greater than 1 for para, and mu r is the lowest for ferro. Mu r value it will be very large for ferro. Mu r is a relative permeability. Less than 1 means அதோட permeability ஓட value வந்து கம்மியாக தான் இருக்கும். It will be 1. It will be less than 1. 1 விட கம்மி. Okay, it will be greater than 1 for para. It's very large for ferro. So relative permeability will be high. The magnetic power it will be very high. So ferromagnetic material will be having the magnetic power it will be high. Okay. Then next one is magnetic field lines. Magnetic field lines. What's the meaning that magnetic field lines? We have to apply the magnetizing field. Okay, the magnetic field lines it will be pass on to the magnetic material. Clear that ma? So magnetic material it will be, so magnetic field lines is repelled by diamagnetic material. What's the meaning that diamagnetic material? We are taking one diamagnetic material. Okay, we have to apply the magnetizing field on the diamagnetic materials. but the diamagnetic material is repelled by the magnetizing field is repelled by the diamagnetic material. So we have to choose one diamagnetic material. We have to apply the magnetizing field on the diamagnetic material. That the magnetic field lines will be repelled by the diamagnetic material. ஒரு மேக்னெட்டிக் ஃபீல்டை நீங்கள் டயமேக்னெட்டிக் மெட்டீரியல் மேலே பாஸ் பண்ணுறீங்க அப்படின்னா டயமேக்னெட்டிக் மெட்டீரியல் வந்து அதை வந்து ரிப்பல் பண்ணும், அதை எக்ஸ்பெல் பண்ணும். தட் இஸ் கால் டயமேக்னெட்டிக் மெட்டீரியல். பட் paramagnetic material, the magnetic fields are attracted towards to the paramagnetic materials. So we have to apply the magnetic fields to the magnetizing paramagnetic materials, that the material will be attracted to the magnetic field lines. Okay, clear that? Then in ferromagnetic material, it will be strongly attracted by the ferromagnetic material. So the magnetic field lines will be strongly attracted by the ferromagnetic material. Clear that, ma? And then susceptibility is versus temperature. Relation between susceptibility and temperature. Okay, relation between susceptibility and temperature means susceptibility is independent of temperature. Susceptibility will be the inversely proportional to the temperature. So directly is independent of temperature means temperature increases, susceptibility does not change. Okay, in the diamagnetic material இருந்துச்சுன்னா temperature change பண்றதுனால susceptibility எந்த சேஞ்சும் ஆகாது. So susceptibility is the independent of temperature, first one, and susceptibility will be the inverse of temperature, inversely proportional to the temperature. What's the meaning? That temperature it will be increases and susceptibility it will be decreases. It will be the vice versa. One increase ana இன்னொரு decrease ஆகும். Okay, and even the ferromagnetic material also susceptibility it will be the inversely proportional to the temperature. Clear that, ma? So temperature it will be increases, susceptibility it will be decreases. So this is the relation between the susceptibility and temperature in the dia, para and ferro. Clear that? And last is the example for dia, para and ferro. Example of dia is bismuth, copper and water. Okay, bismuth, copper and water. Clear that? Copper symbol is Cu. Okay, so I simply explain the first two letters, that is copper. Bismuth, copper and water is the example for diamagnetic material. Aluminium, platinum, chromium is the example for paramagnetic material, and iron, nickel, cobalt are the example of ferromagnetic material. So three types of magnetic materials, dia, para, ferro. That the three magnetic material it will be classified on the basis of these properties. What are the properties? Magnetic dipole moment, force, magnetization and susceptibility, relative permeability, magnetic field lines and the relation between susceptibility and temperature and examples. That all are the classification of types of magnetic materials. In your book one table is there, that not for the top that will be mentioned is not for examination, but you have to learn thoroughly in the inside that the table is not for examination, but individually the diamagnetic, paramagnetic and ferromagnetic you have to learn thoroughly. It will be the asking question. Okay, then so again I tell that all the points. First, diamagnetic material means magnetic power it will be low. ஒரு மெட்டீரியல் வந்து 3 கிளாஸிஃபை பண்ணிருக்காங்க. ஒன்று dia, para and ferro. So first property, magnetic dipole moment. Magnetic dipole moment, we have to apply the magnetizing field to the material. The magnetic dipole moment is there, but in the absence of magnetizing field, no net resultant magnetic moment is there. Movement இருக்காது. Magnetizing field நீங்கள் அப்ளை பண்ணால் மட்டும்தான் மூவ்மெண்ட் இருக்கும். But para and ferro, net magnetic moment is there. Net magnetic moment is there means one magnetic moment it will be moving forward, another magnetic moment it will be in opposite direction. It will be added, so net dipole magnetic moment it will be 0, and ferro it will be having net magnetic dipole moment it will be 0. And then in the presence of magnetizing field, the magnetic moments it will be arranged opposite to the magnetizing field. This will be long lasting. The magnetic field will be present in the material. Magnetizing field எவ்வளோ நேரம் இருக்குதோ அவ்வளோ நேரம் வரைக்கும் it will be aligned opposite to the magnetizing field. But in the magnetic moment, in the para, the magnetic dipole moment, it will be aligned the magnetizing field. Align means it will be parallel to the magnetizing field. It will be long lasting. Whenever the magnetizing field is there, it will be present. எந்த நேரத்தில் எங்கெல்லாம் வந்து மேக்னடைசிங் ஃபீல்ட் வந்து அப்பியர் ஆகிருக்கோ அந்த இடத்துலலாம் என்ன செய்யும் மேக்னெட்டிக் டைபோல் மொமெண்ட் வந்து அரேஞ்ச் ஆகும். ஓகே, தென் ferromagnetic material, the magnetic moment it will be considered as domains. The domains it will be arranged parallel to the field. At domains it will be aligned with the field. Okay, so this is the magnetic dipole moment. And force, we apply the non-uniform magnetic field. We apply non-uniform magnetic field. The material movement is from stronger part to weaker part. எந்த இடத்துல வந்து மெட்டீரியல் வந்து ஸ்ட்ராங்காக இருக்கோ அந்த இடத்துல வந்து வீக்கர் பார்ட் நோக்கி போகும். ஸ்ட்ராங்கர் பார்ட் டு வீக்கர் பார்ட். In para, weaker part to stronger part. In ferro, weaker part to stronger part. Okay. And then magnetization. Magnetization, we are drawing on graph. We have to apply the magnetizing field. Magnetization it will be created in the magnetic material. So magnetizing field it will be increases for the diamagnetic material. The magnetization it will be decreases. நீங்கள் இன்க்ரீஸ் பண்ணால் மேக்னடைசேஷனுடைய ப்ராசஸ் வந்து டிக்ரீஸ் ஆகும். தட் will be in the dia. And the para magnetizing field, magnetization will be increases on the basis of magnetizing field. And ferro, magnetization it will be increases first and it will be reach the high level and it will be going on a constant, okay, for a magnetizing field. And then susceptibility it will be ratio of magnetization to the magnetizing field. It will be positive for dia, negative for dia, positive and small for para, and positive and large for ferro. Okay, and then relative permeability. Relative permeability it will be relate the permeability in medium and permeability in air. Okay, so relative permeability is less than 1 for dia, greater than 1 for para, and very large for ferro. Clear that? And then magnetic field lines. Magnetic field lines it will be repelled by the diamagnetic materials, attracted by the paramagnetic materials. It will be strongly attracted by the ferromagnetic materials. Okay, and then relation between the susceptibility and temperature. Susceptibility it will be independent of temperature. Temperature it will be changed. Susceptibility does not to be changed, or no change is there in with respect of temperature. And susceptibility it will be the inversely proportional to the temperature. So temperature it will be increases, susceptibility it will be increases. And susceptibility it will be the inversely proportional to the temperature also for ferro. So temperature increase and susceptibility decrease on. Then the last point is the example for dia, para and ferro. Dia, bismuth, copper, water, and ferro, para, aluminum, platinum and chromium, and ferro, iron, nickel and cobalt. So you have to learn thoroughly the examples for dia, para and ferro. That is the one word questions. And then what is the magnetization graph for dia, para, ferro? That also asked from one words. Okay, so you have to make one table to learn that dia, para, ferro magnetic powers. Okay, next I will explain that Meissner effect. Meissner effect is nothing but it will be explain the superconducting stage. Superconducting stage means one conductor it will be superconductor it will be act as a diamagnetic material. Or superconductor diamagnetic material மாறும் due to the presence of Curie temperatures. So at a particular temperature the superconductor it will be converted into diamagnetic material, that will be called as Meissner effect. Okay, so in the superconducting stage, in the diamagnetic property stage, the electric field lines is excluded from the magnetic material. For example, we have to take one magnetic material. Okay, we have to apply the magnetic field lines. The magnetic field lines will be parallel to the magnetic material, but we have to increase the temperature at the Curie to make a Curie temperature. The electric field lines is expelled from the superconducting stage. This is a superconductor. The magnetic field lines it will be expelled or excluded. Excluded means expelled from the superconducting stage. ஒரு சூப்பர் கண்டக்டர் நீங்கள் எடுத்துக்கிட்டிங்கன்னா மேக்னெட்டிக் ஃபீல்ட் லைன்ஸ் அப்ளை பண்ணோன்னே மேக்னெட்டிக் ஃபீல்ட் லைன்ஸ் என்னையும் சூப்பர் கண்டக்டர் விட்டு இப்படி போகும். இது இப்போ தான் Meissner effect. So Meissner effect will be explain the superconducting stage. The superconducting material will be converted into diamagnetic material at the Curie temperature. That effect it will be called as Meissner effect. It will be tells by Meissner. Okay, T it will be greater than TC. Temperature Curie temperature நீங்கள் சேஞ்ச் பண்ணும்போது சூப்பர் கண்டக்டர் வந்து டயமேக்னெட்டிக் மெட்டீரியலாக ஆக்ட் ஆகும். தட் will be called as Meissner effect. And what is Curie's law? What is Curie's Weiss law? So Curie's law means Curie it will be tells the one law. to the relate the susceptibility and temperature. Okay, susceptibility, already I told that what is susceptibility. Susceptibility, it will factor, it will be decide the how the material to be magnetized, strong or weak. Okay, and then another one definition is there, susceptibility, it will be the ratio of magnetization to magnetizing field. Okay, so Curie's law, it will be tells susceptibility for a material, it will be inversely proportional to the temperature. So inversely proportional means temperature increase and susceptibility it will be decreases. So for removing the proportionality simple, we put one constant and it will be changed into equal. The equal, it is equal to the constant is C, that is Curie's constant, because C it will be the constant to change the proportionality simple. Okay, so susceptibility, it will be equal to the C by T. C is Curie constant and T is temperature. And Curie's Weiss law means susceptibility in magnetic material, it will be equal to ratio of it will be first it will be directly proportional to susceptibility in magnetic material, it will be changed into it will be directly proportional to T by Tc, T minus Tc. T is the initial temperature for a magnetic material, Tc is a Curie temperature. Okay, at a Curie temperature, the ferromagnetic material, it will be converted into paramagnetic material. Which temperature that ferromagnetic material, it will be converted into para, that magnetic material, it will be called as that temperature will be called as Curie temperature. So Curie-Weiss law is, Curie and Weiss, the two sciences will be discussed the relation of susceptibility and Curie temperature. Susceptibility, it will be inversely proportional to 1 by T minus Tc. T is the initial temperature, Tc is the Curie temperature. So susceptibility in medium is equal to C by T minus Tc. That is the Curie temperature, that the material due to this Curie temperature, ferro to para, it will be converted. Okay, in the temperature ki mele ferromagnetic material para va convert agum. Okay, and then that is Curie's Weiss law. Okay, so you have to already you have to know that Leviated train, magnetic levitated train. Do you know that Leviated train means one train, it will be moving in a track, but no connection between the track and the train, no wheels is there. So one superconducting conductor, it will be fixed at the bottom of the train and the rails, upside of the rails. So some centimeter, it will be gap is there between the train and rail. The train, it will be moving due to the magnetic power. So two magnets, it will be attracted, that the magnets, it will be moving forward and backward, and no connection is there, only the magnetic force is there. That is the phenomenon, it will be used to working of Magno-Levitated train. Magno-Levitated train na onnu illa, or train and track க்கும் ட்ரெயினுக்கும் இடையில ட்ரெயினுடைய பாட்டமில் ஒரு மேக்னெட் வச்சுருப்பாங்க, ரயிலுடைய அப்பர் சைடில் ஒரு மேக்னெட் வச்சுருப்பாங்க. Two magnets will be moving, it will be relate with one another, to contact with one another. Two magnetic force will be attracted between the two magnets. The train, it will be moving to the moving on the magnetic rails due to the magnetic force, due to the magnetic attraction between them. So some meter will be away upside, some meters away from the track to up, konja centimeter mele irundittu it will be moving. So that is called magnetic leviated trains. And next, last and final, I explain that spin. Spin means the magnetic moments, it will be rotated and then it will be making some movements. That the movements, it will be considered as a quantum mechanics. That the movements, it will be explained by the quantum mechanics. That the moments does not to be explained by the classical mechanics. Okay, so the angular momentum, it will be created in the magnetic moments. That is circular spin nale circular rotate agum. Okay, circular motion, rotation motion அப்படினாலே ஆட்டோமேட்டிக்காக குவாண்டம் மெக்கானிக்ஸ் வச்சு தான் நம்ம எக்ஸ்பிளைன் பண்ண முடியும், கிளாசிக்கல் மெக்கானிக்ஸை வச்சு எக்ஸ்பிளைன் பண்ண முடியாது. ஸோ இன் குவாண்டம் மெக்கானிக்ஸ், இட் வில் பி மூவிங் இன் ரொட்டேஷன் மோஷன், ஆட்டோமேட்டிக்கலி ஆங்குலர் மொமெண்டம் இட் வில் பி ப்ரெசென்ட். ஸோ ஆங்குலர் மொமெண்டம் இட் வில் பி கன்சிடர் as ஸ்பின். ஸ்பின் மீன்ஸ் தன்னை தானே ரொட்டேட் ஆகிறது. த ஸ்பின் we have to apply the magnetic induction. Magnetic induction directionலே magnetic moment இருந்துச்சுன்னா, it will be parallel to the magnetization property, the magnetic movements or magnetic spin, it will be parallel to the magnetization, it will be called as spin up. It will be the opposite to the magnetization, it will be called as spin down. The spin, it will be half for electron. So the electron movement, it will be considered as a angular momentum in the atom. That the spin, it will be considered as the value is half. When the spin, it will be half. When the spin, it will be minus of. The magnetic spin, it will be parallel to the magnetization or magnetic induction. It will be called as spin up, and anti-parallel to the magnetic induction, it will be called as spin down. That it will be taken as positive, that will be taken as negative. For proton and neutron, the spin value is half. For photon, the spin value it will be 1. Spin is nothing but the magnetic moment, it will be formed in an angular momentum. Angular, that is circular, one movement we create and the movement is spin. Electron, it will be revolving around the nucleus in the atom. Okay, so electrons is having the spinning around, it will be produce the angular momentum. That the spin value it will be half, but the spin it will be in the parallel to the magnetic induction, it will be spin up. Due to the magnetic anti-parallel to the magnetic induction, it will be called as spin down. Okay, for proton and neutron, the spin is half. For photon, the spin value is 1. So, okay, in the today's session I explained what are the types of magnetic materials. What are the types of magnetic material? Dia, para and ferro. And what are the property? It will be explained the dia and para and ferro. Magnetic dipole moment, force, magnetization, susceptibility, permeability, magnetic field lines, and relation between susceptibility and temperature. An example for dia, para and ferro. Okay, that are all the properties. It will be explained the types of magnetic materials. Okay, the relative permeability value, it will be the frequently asking question, one word question. Okay, relative permeability is less than 1 for dia, relative permeability is greater than 1 for para, relative permeability is large for ferro. And then susceptibility value also. Susceptibility, it will be negative for para, positive for ferro and small for para, and positive and large for ferro. Okay, clear that? And then magnetic field lines expelled by diamagnetic material, attracted by diamagnetic material, strongly attracted by diamagnetic material. And then relation between susceptibility and temperature. Susceptibility is independent of temperature. Susceptibility will be inversely proportional to the temperature. Susceptibility is inversely proportional to the temperature. So that all are discussed in this session. And as well as Mason effect, Maglow levitated train, and Curie's law. Curie's law is susceptibility is inversely proportional to the temperature. So removing the proportional, we put on constant, that is C by T. Susceptibility is equal to C by T minus C. Curie temperature means that the particular temperature, the ferromagnetic material will be converted into paramagnetic material, and that is Curie's Weiss law. And spin is half for electron, and spin is half for photon and neutron. Spin, it will be equal to 1 for photon, and spin it will be classified into 2, that is spin up and spin down. The magnetic moment induction direction, the spin movement is there, that the spin it will be considered as spin up. The magnetic induction direction, the spin it will be moving anti-parallel with the magnetic induction, it will be called as spin down. So it will be taken as negative. Okay. So in the session I explained types of magnetic material, Mason effect, Magnow levitated train, Curie's law, Curie's Weiss law, and spin. Okay. And today homework. So home assignment for today's session, learn and write types of magnetic materials. Types of magnetic materials. And Curie's law, Curie-Weiss law, and Mason effect. Students, note down what is the homework ma? Learn and write the types of magnetic materials, Curie's law, Curie's Weiss law, Curie-Weiss law, and Mason effect. Okay, thank you.